Siamo sulla spiaggia di Cesenatico in pieno inverno.
It's the dead of winter, and we are on Cesenatico Beach. In 4 or 5 months, this beach will be bristling with beach umbrellas. But what are the problems this beach has? The sand on this beach has always been carried by rivers. However, over the past 50 years, it has started to erode. Breakwaters were used to defend the beach for 50 to 60 years. Later, we noticed that they profoundly transformed the environmental landscape, changing the dynamics of the coast and altering and making the quality of both bathing water and the sea bottom worse. We were faced with the problem of having to discover an alternative to breakwaters. The first coastal plan of 1981 found and identified an alternative for Emilia-Romagna. It is to bring in sand from elsewhere in order to rebuild eroded beaches. From a morphological point of view, the Emilia-Romagna coastline is entirely comprised of low, sandy beaches. As a result of these features, approximately 90% of its 130 kilometers is affected by intense seaside tourism. These beaches have always been fed by sand carried to the sea by numerous rivers whose mouths are located along this coast. Over the course of the last century, many beaches began to be strongly affected by erosion, primarily as a result of human activity. Specifically, leading causes include the decrease in the amount of sand being transported to the sea by rivers, subsidence caused by the massive extraction of groundwater and methane, which has caused a lowering of the coast by approximately 1 meter for 100 kilometers, the construction of maritime works, piers and breakwaters. Breakwaters in particular were first created as a form of defense against the sea. Over time, however, they have become a cause of erosion since they diverted onto neighboring coasts. It is because of their great impact on the environment that the region of Emilia-Romagna decided to resort to artificial beach nourishment in 1981. With beach nourishment, sand is brought in from outside to maintain the equilibrium of the beach. Where can we find such large quantities of sand? Over the past 20 years, our primary source has been ground caves. Then, in 2002, the region implemented its first intervention using sand from sea bottom deposits. Most people believe that the sea bottom in front of a beach is sandy, but that's not true. In front of the Emilia-Romagna coast in the Adriatic, the sea bottom is muddy for approximately 35 kilometers. Sand is found beyond this, but in layers of just a few meters in depth. As such, they are not suitable for use. Therefore, specific research must be carried out to identify areas where the sand layer is over a meter in depth. Planning research on sandbanks in the sea is a very complex and highly specialized activity. In order not to work in the dark, the first thing to do is collect information and data on the continental shelf. This is why we must turn to petrol companies or research institutions. For example, since 1983, ARPA Ingegneria Ambientale has been working with the Istituto di Geologia Marina of the CNR in Bologna, now ISMAR. This institute has been responsible for carrying out more research than any other on sedimentological features in the Adriatic Sea. A geophysical campaign can be planned and implemented once these areas have been identified. Specific seismic acoustic instruments are installed on a ship or on a towed raft. The boat then navigates for miles at a speed of 3 to 4 knots along previously plotted routes in the area in question, recording data on the sea bottom and on its first few underlying layers. An analysis of the data collected provides valuable information on the width and depth of the sedimentary deposits which make up the sea bottom, but not on their nature. To see whether the layers in question are sandy, a geognostic campaign must be carried out and core samples must be collected from interesting points identified using our geophysical profiles. As such, in terms of operations, we need to return to the area under investigation with a suitable ship and a vibrocorer. A vibrocorer is an instrument which is essentially comprised of a 3 to 6 meter long steel tube connected to an electric motor which produces vibrations. A plastic tube of the same length as the steel one is inserted inside it and fastened into position using screws. A cylindrical instrument with retractable flaps is positioned at one end, allowing the material to enter the tube but not to leave it. This is known as a core catcher. Once set, the vibrocore is lowered onto the bottom of the sea using a crane and a steel cable. It is then connected to the generator. The motor is started, and this provides the vibrations which push the tube into the sea bottom. If the layers are muddy, the vibrocore easily penetrates the sea bottom down its entire length. On the other hand, if the layers are sandy, the length of the sample may vary based on its features. Once the vibrocore passes the sandy layers, it reaches an ancient plain dating back to the Ice Age, which is comprised of consolidated layers of clay and stops after a few decimeters. In any case, after vibrating for a few minutes, the vibrocore is lifted back onto the ship and positioned horizontally so that the plastic tube can slide out. For ease of transport, this is cut from the bottom to the top into 1 meter segments and sealed at both ends with colored plugs which are initialed with the sampling station, the number of the segment, and information on the high or low part. A number of different vibrocorers have been used over the course of 6 research campaigns carried out by the region of Emilia-Romagna on sandbanks in the Adriatic starting in 1984. Initially, these were very heavy and bulky. The latest one, instead, is very light and simple to use. This is a great advantage because smaller, faster boats can be employed, reducing time and costs. During the course of the campaign, which ended on the 10th of January 2008, the vibrocorer was used to extract 7 cores a day during the last 3 days, operating 35 miles from the coast and returning to land each evening. The core segments were stored in the walk-in fridge at Isma Cianere in Bologna. In January and February, they were sectioned lengthwise in order to be photographed, analyzed, and described. Sand samples obtained from each of the segments were subjected to granulometric analysis. In total, 32 cores from 3 distinct areas, known as A1, C3 and H, were taken during the geognostic campaign, funded by Resame and the region of Emilia-Romagna. Areas A1 and C3 had already been explored in the 80s and 90s. The presence of sand was certain, but further information on the extension and volume of sedimentary deposits needed to be acquired. This is a discovery of strategic importance because it potentially increases the amount of sand available to guarantee the equilibrium of the Emilia-Romagna coast in the future. Dredgers and other currently available techniques, in fact, allow us to reconstruct several kilometers of eroded beaches in just a few weeks. The region of Emilia-Romagna carried out the first intervention of this type in 2002. In 2002 and 2007, the region funded 2 extractions of 800,000 cubic meters of sand from 2 of the 5 sandbanks discovered during the first investigation carried out in the 80s, beyond the coast of the region on the sea bottom at depths of 34 to 40 meters. 800,000 cubic meters of sand were taken from sandbank C1 and carried to 8 separate beaches for an overall length of 9 kilometers, widening them by 30 to 40 meters. 800,000 cubic meters of sand were taken from sandbank C1 and carried to 8 separate beaches for an overall length of 9 kilometers, widening them by 30 to 40 meters. The results were outstanding, as proved by 3 years of monitoring carried out by ARPA Ingegneria Ambientale on the beaches and on the area from which the sand was taken, and spurred the region to carry out a second 800,000 cubic meter intervention in 2007. Submarine sandbanks are a resource of strategic importance to guarantee the future of beaches on the Emilia-Romagna coast. This is why they must be protected and used only in case of real need. In fact, every effort must be made to improve the state of the coast by reducing the causes of erosion before the sand is employed. This is the only way we can guarantee a bright future for the coastal environment, which is so important to the landscape, environment, tourism and economy of the region as a whole.